Yes, I welcome to my YouTube channel. As usual, Engineer Steve Electric. Then our topic today is Ohm's law part 2. Remember, we finished part 1 with how you find current, voltage, then resistance. Now we are going to find power using Ohm's law. Please subscribe. Our topic today is how do you find power in the circuit using Ohm's law. By the way, what is power? Electrical power. Electrical power, now it is electrical power. Electrical power is the rate at which energy is absorbed within a circuit. For example, like things that absorb power, we have electrical cookers, we have bulbs, we have heaters, we have electrical kettles, that is the percolators. What they absorb electrical power and convert it into heat or light or both. There are those who convert it into both, like bulb. The moment you put the switch on the bulb, so it takes some like 5 minutes, you touch on the bulb, you'll find the bulb is almost heating and at the same time giving light. Now, many people have been asking, hey, how do you use Ohm's law to find power? The solution is here. Just subscribe to my YouTube channel, Engineer Steve Electric. Subscribe. Remember, as I told you earlier, that examples of things that absorb electrical power, like light bulbs, heaters, we have cookers, we have electrical kettles, we have many of them. But they absorb power. They absorb electrical power and convert it into either heat or light or both. As I told you, like the bulbs, what they convert into light and heat. So the higher their ratings in watts, the more power they will consume. Like you are having a 100 watt bulb. You know those bulbs. They don't absorb power like this 5 watt. It means that this 100 watt they will consume more power than this one. So what? Now with the how do you know that? Or how do you calculate the amount of power you are using in the circuit or at your home? Now we are going to find it. It is very easy. Just subscribe to my YouTube channel, Engineer Steve Electric. Remember, there is a reason why we are using W, yet we are calculating for power. The reason being that the system unit, the system international unit or the SI unit for power is measured in watts. You may find kilowatt, watt, but it is watts. So now I'm going to give you an example. The formulas for calculating power using Ohm's law, as we saw in the previous video I uploaded there. So keep on following my YouTube channel so that you don't miss more videos are still coming about Ohm's law. Yes, like here we are having these 3 triangles. Remember, even the other first video using these 3 triangles. Here we bisect into 3 portions. Here we are going to put power, voltage, current. Power, voltage, current. Power, voltage, current. In the simple term that power is the product of voltage multiplied by current flowing in the circuit. That is the way you can define power. Yes, that power is a product of voltage multiplied by current flowing in the circuit. Now here we are finding power now. Here we cancel P. Then P equals voltage times current. Here we are going to cancel V. You can also find, once you are given power, you can also find then the current here, V equals power divided by current. Here we are going to find the current, therefore current equals power divided by volts, voltage, but in volts. Here it is in watts, current in amps. Remember, current is measured in amps, voltage measured in volts. So now we are going to see here a simple example. Just subscribe, comment, share, like the video. Now you remember, all electrical components are given power ratings in watts. You may find there the bulb is having 5 watts, 3 watts, 7 watts. They are given, or they are rated in watts. So that indicates that the maximum rate at which the components convert the electrical power into forms of energy, into other forms of energy. Like we have forms of energy, like we have heat, we have light. Those are forms of energy. And so subscribe my YouTube channel. Like electrical devices convert one form of energy, one form of power into another. I'm repeating, electrical device convert one form of energy, one form of power into another. For example, electric motors convert electrical energy to mechanical energy. Those are electrical motors. So you may find that electrical generator, for them, they convert mechanical to electrical energy. Note that, because it is asked that electrical motors convert this into what. So those one who are still in O level, they will see that objective. So electrical generators, they convert mechanical form to electrical energy. Then light bulbs, for them, they convert electrical energy to both heat and light. As I told you, for them they convert heat and light. But motors, they convert electrical force to motors convert electrical energy to mechanical force. But as I told you earlier, that the system international unit for power is watts. But you may find in other electrical components when there is HP. What does it mean? Horsepower. Like in pumps, water pumps, you may look for watts. You may not find there watts, but you may find HP, that is horsepower. For pumps, water pumps, they use horsepower, but the difference is simple. That is 1 horsepower, like it is 1 HP equals you may convert horsepower into watts by, so 1 horsepower equals 746 watts. That is 1 horsepower. So if you may say that my pump is having 1.5 HP, that is horsepower, is 1.5 HP. You convert it into watts, that is 1.5 times 746. So here you get the answer by multiplying that one. So that is how you convert horsepower to watts. In electrical pumps or water pumps, for them you may not find there watts, but you may find there HP, which means horsepower. So let us see here the example. Now, we are having our examples here. Now we are having a circuit with the 24 volts and with the current of 2 amps with the resistance of 12 ohms. So now we want to find the power consumed by the bulb. How do you find the power? Now we are going to use, you can either use this or this. It is you to select the formula to use. Let me use this. That is, now we are finding power. You don't have power there. Therefore, power equals voltage times current. We are having our voltage is 24. That is 24 times 2. That is 48 watts. Don't forget to put there watts. Remember, I told you that power, the SI unit for power is watts. Now you may also find the current. Let me say that there is no current. So let me show you there was no current, and you are told to find. So here you can also use this to find the current, or you can either you can use it this one. Let me use this one. Okay, let me use this one because here it is directed. Let me give you the simple way how you can use one formula to get the answer. That is, but still I can also use this because I have power. Let me see, power equals voltage times current. Remember, I don't have current, so I have power. That is 48 watts. Okay, it is voltage is 24 times current. Remember, you are looking for current. So here we have 48 equals, that's 24 times current, that is 24 current. So here we divide by as I told you, power equals voltage times current. Here we're looking for power, that is 24 times 2, that is 48 watts. So now we are looking for let us assume that current, we are not given current, so we have power now for 48 watts. Now we don't have current, so here you can use this the same formula, that is power equals voltage times current. That is, you have power, that is 48 times 48 equals 24 times current. That is 48 equals 24 current. So we divide by 24. Divide by 24. Therefore, current equals 2 amps. So that is a simple way of finding power using Ohm's law. As simple as that. So subscribe, share, so that if you are like in here, or you are a student in O level, A level, technical, that is a way how you can find power, most especially those who are doing electrical science and engineering. So subscribe to my YouTube channel, Engineer Steve Electric. We are still uploading. We will start with the Ohm's chart. We will be uploading more videos. Thank you for watching Engineer Steve Electric YouTube channel. Subscribe, comment, share. Thank you.